10 years ago, solar power was an expensive dream reserved for wealthy companies and governments. Today, solar has become one of the cheapest ways to generate new electricity, and the next major breakthrough may have less to do with improving solar panels and more to do with how quickly we can manufacture and install them. For years, the energy industry focused on making solar panels more efficient, developing better materials, and increasing their power output. But something else is now becoming just as important as automation. AI-powered robots are beginning to transform the way massive solar farms are constructed, while Tesla is pursuing an even bigger vision involving solar manufacturing, battery storage, artificial intelligence, and automated deployment. And if these technologies scale the way the developers expect, the cost of building renewable energy infrastructure could fall dramatically. Just think about what is required to build a utility-scale solar farm. A project can contain hundreds of thousands or even millions of individual panels. Every panel has to be transported to the correct location, lifted onto a mounting structure, positioned precisely, and secured. Then the process starts again. And again. And again. For a huge solar farm, workers may have to repeat this process hundreds of thousands of times. That means enormous amounts of labor, transportation, equipment, and construction time. And while solar panels themselves have become dramatically cheaper over the past decade, installation remains a major part of the overall project cost. This is where robotics could change everything. Instead of relying almost entirely on human workers to move and install panels, companies are developing specialized machines capable of performing the most repetitive parts of solar construction automatically. One example is a large tracked robotic system developed for utility-scale solar construction. The machine is designed specifically for panel installation. It can move across large construction sites using tracked wheels, navigate uneven terrain, locate mounting structures, and position solar panels with high precision. The advantage isn't simply that the robot can perform the same task as a human. The bigger advantage is that it can potentially perform that task continuously and consistently. It doesn't need lunch breaks. It doesn't get tired after installing hundreds of panels. And it can operate in conditions that would be extremely difficult for human workers. If these systems can be deployed at scale, they could reduce the amount of manual labor required to construct enormous solar farms. That could shorten construction timelines while also reducing costs. Some estimates suggest that automated installation could potentially reduce solar construction costs significantly, although the exact savings will depend on the project, technology, and level of automation. And this isn't happening only in the United States. China has also been experimenting with robotic systems for solar installation, inspection, and cleaning. Some autonomous cleaning robots can move across solar arrays, removing dust and debris without requiring large teams of workers. Other systems are being designed to inspect panels for damage and identify problems before they become major failures. This creates an interesting possibility. The future solar farm may not simply be a field filled with panels. It could become a highly automated energy facility where robots construct the installation, maintain the panels, inspect the equipment, and continuously optimize operations. And that's where Tesla's broader energy strategy becomes especially interesting. To many people, Tesla is primarily an electric vehicle company. But Elon Musk has repeatedly described a much larger vision. Generate electricity with solar power. Store that electricity in batteries. Use it to power homes, businesses, vehicles, and eventually entire communities. Tesla has already expanded significantly into energy storage, and the company has continued investing in large-scale battery production. At the same time, Tesla has been associated with plans for much larger solar manufacturing capacity. The idea is straightforward. If you want solar energy to become a dominant source of electricity, you need enormous quantities of solar panels. But manufacturing panels is only one part of the problem. You also need to install them. You need to connect them to the electrical grid. And because solar generation changes throughout the day, you need massive amounts of energy storage. That means three different challenges have to be solved at the same time: generation, storage, and deployment. Tesla is increasingly positioning itself around all three. The company has been developing energy storage products, such as Megapack, while continuing to expand its energy manufacturing footprint. Tesla's energy storage business has also become an increasingly important part of the company. Recent quarterly deployments have demonstrated how quickly demand for large-scale batteries is growing. And that growth matters because solar energy has one fundamental weakness. The sun doesn't shine all the time. Solar panels can generate enormous amounts of electricity during the day, but production falls when the sun goes down. Battery storage solves part of that problem. During periods of high solar generation, excess electricity can be stored. Later, when demand increases and solar production falls, those batteries can send electricity back into the grid. This turns intermittent solar generation into something much closer to a reliable energy resource. And if Tesla can combine massive solar manufacturing with massive battery production and automated solar construction, the potential scale becomes enormous. Imagine a future where factories produce solar panels at an enormous rate. Those panels are transported to massive construction sites. Autonomous machines install them. Robots maintain them. And giant battery systems store the electricity they generate. That begins to look less like a traditional solar farm and more like an automated energy factory. Tesla's ambitions extend beyond energy as well. The company is simultaneously investing heavily in artificial intelligence and robotics. Its custom AI processors are being developed for vehicles, autonomous driving systems, Optimus, and potentially large AI computing infrastructure. That creates an interesting connection between Tesla's different businesses. The same AI technology that helps a vehicle understand its surroundings can also help a robot navigate a factory. And similar automation technologies could eventually be used to build and maintain energy infrastructure. In other words, Tesla isn't necessarily developing these technologies as completely separate projects. They can potentially reinforce each other. AI improves robots. Robots reduce construction costs. Cheaper construction allows more solar farms to be built. More solar generation creates greater demand for energy storage. More battery storage makes renewable energy more useful. And greater energy deployment creates an even larger market for Tesla's energy products. That's the bigger picture. But there's another problem critics often raise when talking about massive solar farms. Land. If millions of solar panels are installed across huge areas, what happens to agriculture? Does solar power compete directly with food production? The answer isn't always as simple as one or the other. One increasingly interesting solution is agrivoltaics. That's the practice of combining agriculture with solar power on the same land. And some large solar projects are already demonstrating how this can work. In Australia, large solar farms have incorporated livestock grazing beneath and between solar panels. Instead of removing agriculture completely, the land can continue producing food while also generating electricity. This can create some surprising benefits. The solar panels provide shade during extremely hot weather. That can help reduce heat stress for livestock. The panels can also influence the local microclimate around the ground. Depending on the location and design, shaded areas may retain moisture longer and provide more favorable conditions for vegetation. And there is another advantage. Animals can naturally control vegetation beneath the panels. Instead of relying entirely on mechanical mowing or chemical herbicides, livestock can graze around the solar infrastructure. That can potentially reduce maintenance requirements. So instead of thinking about solar farms as land that becomes unusable for agriculture, we can start thinking about some solar installations as dual-purpose infrastructure. The same land can produce electricity and support agricultural activity. Of course, agrivoltaics isn't suitable for every crop, every climate, or every solar project. But it demonstrates that renewable energy and agriculture don't necessarily have to be opposing forces. And that becomes increasingly important as global electricity demand rises. The world needs more electricity. Artificial intelligence requires enormous amounts of computing power. Data centers are expanding. Electric vehicles are becoming more common. Factories are becoming increasingly automated. And eventually, millions of robots could also require electricity to operate. All of these trends point toward one fundamental requirement: more energy. And not just more energy. More affordable energy. That's why the cost of generating and storing electricity matters so much. If solar panels become cheaper, batteries become cheaper, and robotic construction reduces installation costs, the economics of renewable energy could improve even further. And that's where Tesla's long-term strategy becomes particularly ambitious. The company isn't simply trying to sell more cars. It's trying to participate in an ecosystem where electricity is generated, stored, distributed, and consumed through increasingly intelligent machines. Electric vehicles can consume that electricity. Megapack systems can store it. Solar panels can generate it. AI can optimize the system. And robots could eventually build and maintain much of the infrastructure. This is a much bigger vision than simply replacing gasoline cars with electric vehicles. It's about changing the infrastructure that powers the entire economy. But there are still major obstacles. Solar manufacturing requires enormous amounts of capital. Building factories takes years. Large solar projects require permits, grid connections, financing, and suitable land. Battery production depends on complex supply chains. And robotic construction systems still need to prove that they can operate reliably and economically at massive scale. So none of this is guaranteed. The technology may be advancing rapidly, but deployment is what ultimately matters. Still, the direction of the industry is becoming difficult to ignore. Solar panels are getting cheaper. Battery storage is expanding. Robotics are entering construction. Artificial intelligence is becoming more capable. And companies like Tesla are attempting to connect these technologies into a single ecosystem. The most fascinating part is that each improvement can potentially accelerate the next one. If robots reduce installation costs, more solar projects become economically attractive. If more solar projects are built, demand for batteries increases. If battery prices decline, solar becomes even more valuable because stored electricity can be used when the sun isn't shining. And if AI and robotics continue improving, the entire process can become increasingly automated. That creates a powerful feedback loop. The future of energy may therefore look very different from the energy system we know today. Instead of enormous numbers of workers manually constructing infrastructure, autonomous machines could increasingly handle repetitive tasks. Instead of electricity being generated almost entirely by centralized fossil fuel plants, power could come from millions of solar installations distributed across huge areas. Instead of allowing excess solar electricity to go unused, massive battery systems could store it. And instead of treating agriculture and energy generation as completely separate industries, some projects could combine both on the same land. Tesla is trying to position itself directly inside this transformation. Solar manufacturing, battery storage, artificial intelligence, robotics. autonomous machines, and electric transportation. Put all of these pieces together, and the bigger picture becomes much easier to understand. Tesla's ultimate opportunity may not be selling millions of electric cars. It could be building an interconnected ecosystem where machines generate energy, store energy, transport people, perform physical work, and increasingly make decisions using artificial intelligence. And if AI-powered robots really can reduce the cost and time required to build solar farms, the impact could extend far beyond Tesla. It could accelerate the global transition toward cheaper electricity. It could allow more solar projects to be built in more countries. It could make energy storage increasingly important. And it could create a world where clean electricity becomes not just environmentally attractive, but economically difficult to ignore. Perhaps that's the most important lesson here. The next solar revolution may not come from a single breakthrough in solar cell efficiency. It may come from combining several technologies that already exist and making them work together at enormous scale. Better manufacturing, smarter robots, cheaper batteries, artificial intelligence, and massive deployment. When those pieces come together, solar power could become far more than an alternative source of electricity. It could become the foundation of a new energy economy. What do you think about Tesla's massive energy ambitions and the rise of AI-powered robots in solar construction? Do you think automation can make solar power dramatically cheaper and accelerate the global transition to renewable energy? Let us know your thoughts in the comments below. If you enjoyed this deep dive into Tesla, solar energy, AI, robotics, and the future of clean technology, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss our next update. Thanks so much for watching and for supporting the channel. We really appreciate it. We'll see you in the next video. Until then, take care, stay safe, and keep watching the future unfold.